Hello, everyone, and thank you for joining us. My name is Juliet, and I will be the moderator for today's webinar. Before I pass it off to our speaker, let me cover a few housekeeping items. At the bottom of your screen are multiple engagement tools you can use. All tools are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your presentation area or maximize it to full screen by clicking on the arrows in the top right corner. If you have any audio or video issues, you can find answers to some common technical issues located in the Help widget at the bottom of your screen. Please note that a copy of today's slide deck and additional resources are available in the resource list. Please have a look and download everything that you may find useful. Also, the webinar will be recorded and sent via the email you registered with. Lastly, if you have any questions during the presentation, you can submit them through the Q&A widget. We're here to answer you live via the chat, so don't hesitate to reach out throughout the presentation. Now, I'd like to introduce our speaker today. Today, we're joined by Matt Mickle. He is the Director of Automotive and Semiconductor Solutions here at Jama Software, with a focus on providing solutions and consulting to the unique needs of this market. He has over 10 years of experience working with hundreds of Jama Connect customers on the requirements and systems engineering processes, and moved from the US to Europe in 2017 to help start and build the team at Jama Software's EMEA headquarters in Amsterdam. And with that, I'll pass it over to you, Matt.
Welcome, everyone, and thanks for the introduction, Juliet. We have a fun topic today, walking through variant management use cases with the goal of simplifying this sometimes complicated topic. I will start off by walking through some of the common use cases that we often hear, followed by some concrete examples of how we would see these within the industry. I'll talk a little bit about how we'll solve these within Jama Connect, and then have some demonstration of this directly in the tool. I'll do this for each use case as we proceed, and then we'll move on to some Q&A and I'll answer some of your questions. So, what do I mean when I say variant management? Well, simply, I would describe variant management as any process or technique that is used to manage variability in assets within a project. This could be in the form of certain techniques such as feature-based product line engineering, which we'll talk a little bit more about later, configuration management, product derivation, or branch and merge. A product can vary in many ways, such as different features, material or components, premium services, or levels of performance. Here are some examples you might recognize. Models of home appliances with different sizes or capabilities, like these refrigerators. Microcontrollers with a configuration of reusable IP blocks. Medical devices, such as insulin pumps or digital thermometers, having an array of features based on setting, method of application, or type of consumer, as well as everyday devices such as smartphones or smartwatches with different uses or consumer profiles. Nearly every product you could think of has some amount of variation, and the process of managing those variants extends from the conception of the products all the way into their description at the point of sale and maintenance thereafter. So one of these methods, which we will mention in the discussion today, is product line engineering, or PLE for short. And for this, we'll use the simple definition: a focus on engineering for a family of products with similar features, components, or modules as a single product line to leverage commonality and variability, minimize the duplication of effort, and maximize reusability. Now, a couple of definitions that go along with that from the standards for product line engineering. From ISO 26550, the definition of a feature would be an abstract functional characteristic of a system of interest that end users and other stakeholders can understand. And from the product line engineering for feature-based product line engineering standard, ISO 26580, a product line would be a family of similar products with variations in features. So Product line engineering could be considered as the next step in maturity, single system engineering. And as the ISO standard on software and system engineering for product line engineering and management states, product companies utilizing single system engineering and management approaches may end up with highly complex and low quality products, low productivity, high employee turnover, and less than expected customer satisfaction. So let's instead talk about the benefits of moving from single system engineering into product line engineering. Product line engineering enables organizations to create product line architecture that allows for the systematic reuse of components, modules, and assets across different products within a product line. This promotes efficiency by reducing redundancy and the need to recreate similar functionalities for each product. By reusing existing components and assets, organizations can significantly reduce development costs. Product line engineering allows for economies of scale, as the investment in creating a core set of assets can be spread across multiple products, leading to cost savings in the long run. With product line engineering, organizations can streamline the development process by leveraging existing components and architectures. Faster time to market for new products, since development efforts are focused on creating unique features rather than rebuilding common functionalities. Product line engineering helps ensure consistency in products across the product line. By reusing well-tested and validated components, the likelihood of introducing defects or inconsistencies is reduced, and this will lead to higher overall product quality. As market demands change or new technologies emerge, product line engineering provides a framework that allows organizations to adapt and evolve their product line more easily. This enables the addition of new features or modification of existing ones without starting the development from scratch. Product line engineering supports efficient configuration management, allowing organizations to define and manage variations in products through configuration rather than by creating separated versions or desynchronized copies of content. This simplifies the task of handling different customer requirements or market-specific adaptations. Product line engineering makes maintenance and upgrades more manageable. Changes or bug fixes can be applied to common components, and then the updates can be propagated to all of the products within the line, ensuring that each product benefits from the improvements without having to undergo individual modifications. And finally, product line engineering helps mitigate the risks associated with product development by relying on well-established and proven components. Since these components have been used and tested across multiple products, the likelihood of critical issues arising is reduced. Now, of course, there are many benefits for product line engineering, but there are a lot of challenges that a company goes through in order to try and move towards product line engineering. For example, let's say a company starts out with a single product and then begins to build variants on that product, turning it into a product line. As the number of variants and variation between them grows, the ability to manage them becomes more and more challenging. When a change is made, it's important to assess not only the impact of that change within the product, where the change is made, but also in any products that are part of the same product line. If the change is against common requirements, then a decision is needed on whether they need variation. New versions or configurations of components of a system will need to be thoroughly reviewed with regards to how they interconnect. This becomes even more challenging and complex when considered as the product development data moves from one development application to the next. Throughout the supply chain, information about progress and change needs to flow and be collected in order to see overall status. It's very difficult to collect and understand this with only a single complex product and increases exponentially with variation. Now, within the context of the content included in Jama, the task of managing variants begins once there is any notion of more than one product being developed which has common requirements to another product. The question then arises of how to maximize reusability and still understand the impact across multiple variants in the most efficient and effective way.